This is the first section of Chapter 3, 3A, where we will talk about uses and abuses of percentages. Three ways in which we can use percentages are as fractions. For example, a total of 13,000 newsroom employees, 2.6% of the newsroom workforce lost their job. Another one would be to describe change. Our company's stock fell 15% last week to $44.25. Or to do a comparison, the new battery lasts 175% longer than the older one, but costs 10% less. Looking at an example here, it says an opinion poll finds that 35% of 1,069 people surveyed said that the president is doing a good job. How many said that the president is doing a good job? So the word of always represents multiplication. So anytime you're reading and it says this percent of this number means you're going to do some form of multiplication here. And when we do that multiplication, we have to change a percent into its decimal equivalent. Percent literally means per 100. So percent equals per 100. So 35% is 35 out of 100, or the decimal 0.35. We're going to do 0.35 times 1,069 and get roughly 374 people. So we found 35% said he was doing a good job. That was 374 of the 1,069 that we surveyed. Okay, looking at another example here, we want to express the first number as a percent of the second number. In 2019, there were 61 million Americans under the age of 15 and a total of 328 million Americans. So this wants us to create a percentage based on a comparison of two numbers. So we want to take 61 million and divide that by 328 million. Now, million means there are 6 zeros. So 61 with 6 zeros over 328 with 6 zeros. All you have to do is grab a calculator and take this top number divided by this bottom number, and you're going to get a decimal value of 0.186, and that is the decimal. But we want this as a percent. So to go from decimal to percent form, I'm going to multiply by 100 because percent means per 100. So I want to turn it into a percent. I'm going to times it by 100. 18.6% of our American population is under the age of 15. With percents, we have the option to calculate what is called a relative change. So the first part is absolute change. Absolute change is going to describe the actual increase or decrease. This is not a percent value. This is just, I went from 4 degrees to 10 degrees. I increased by 6 degrees. So you're just going to calculate that. Relative change is going to use a fraction to then give us a percent value. And the formula for this is going to be, you take the new value minus the reference value all over the reference value, and they're going to times it by 100. So this is going to give me the percent change that occurred, where this absolute change is going to just tell me how much did I go up or down numerically. During a 6-month period, Lunar Industries stock doubled in price from $7 to $14. What were the absolute and relative changes in stock price? Well, absolute change just wants us to calculate that difference. And you can see that there. 14 minus 7 increased by $7. Now, to find the relative change, you're going to take that value that we started with, 14 minus 7, but now we need to divide that by our starting value, 7. So that makes 7 out of 7, which is 1 times by 100, means we had a 100% increase. I went from 7 up to 14. That is a full 100% increase. I increased by 7. You bought a new laptop computer 3 years ago for $1,000. Today, it's only worth $300. Describe the absolute and relative change in the laptop's value. Well, we started with a value of 1,000 and now it is currently worth 300. So the absolute change takes that new value of 300 minus the original of 1,000 and we've gone down $700. So that makes negative 700. That negative sign tells us that the computer's current worth is $700 less than what we paid 3 years ago. So to find the relative change, we're going to take that same value that we got, negative 700, and divide by the original price, 1,000. And that gives me negative 0.7, which I then have to multiply by 100 and get negative 70%. Again, that negative sign tells us that it went down. So the laptop is 70% less than what it was 3 years ago. Kyler's salary increased from $25,000 to $35,000 over a 3-year period. Whitney's salary increased from $30,000 to $42,000 over that same period. Whose salary increased more in absolute terms and then in relative terms? So I'm first going to work with Kyler. And we went from 25,000 to 35,000. So 35,000 minus 25,000 is a $10,000 relative, increase. If we then want to find relative, we're going to take that value, 10,000, divided by the initial 25,000, times it by 100, and you will see that you get a 40% increase in salary. Working with Whitney, she went from 30,000 to 42,000. So 42,000 minus 30,000 is a $12,000 increase. So we can see right now, Whitney, in absolute terms, did better. Let's check the percent change. So we went up 12,000 from an initial value of 30,000. We're going to times that by 100. And when I do that, I also get 40%. So in absolute terms, Whitney did better. But in percentage terms, they actually both increased the same. So we can also talk about absolute difference and relative difference. It's the same exact thing as absolute change and relative change. They just change the word from change to difference. So the absolute difference, again, takes our compared minus reference, And then the relative difference is going to take that absolute difference divided by our reference value and then times by 100. Same formulas, same process. Recent data showed that California ranked first among the 50 states in average income at about $68,900 per person, and West Virginia ranked last at $46,600 per person. Two questions. How much lower is average income in West Virginia than California? And then how much higher is average income in California than West Virginia? We're going to do both of these in absolute and relative terms. Starting with part A, we can find the absolute difference by taking the 46,600 minus the 68,900. This is because it asked how much lower is West Virginia than California. So we got negative $22,300. West Virginia is $22,300 less than California. Now, if we want to compute the relative difference, we're going to take that negative $22,300 divided by California's total, that reference value, which we have up here. Reference value is this one. Oops, and then times by 100. And that is going to give me negative 32.4%. So West Virginia earns roughly 32.4% less than California. Just a reminder that that negative sign tells us that West Virginia is less than California by $22,300 total, or 32.4%. So that means when we work the other way around and we want to figure out how much more California earns from West Virginia, the absolute difference is now going to be 68,900 minus 46,600. And I get that 22,300, but it's now positive because California is our first value, our compared value. To now calculate the relative difference, we're going to take that positive $22,300 and we are now going to compare it to the reference value of West Virginia, which was 46,600, and times that by 100. This is going to give me 47.9%. So we found that California earns more than West Virginia by $22,300, which is about 47.9% more. As of 2020, the life expectancy at birth of American women was 81.1 years, is what percent greater than the life expectancy of men, 76.1 years? So we want women compared to men. So women minus the men divided by the man's value times by 100 is going to give me about 6.6%. So women live about 6.6% longer than men. Another way we can use percents is to compare more than or less than. If a newer compared value is so much percent more than a reference value, then it is 100 plus that percent of the reference value. So if I'm 25% more than something, it means I am 125% of the reference value. And the same works for less than. So if a newer compared value is some percent less than, so let's say 30% less than the reference value, it is, you take 100 minus 30, 70% of the reference value. So you can go between the of and the less than or more than. Jada earns 200% more than Reggie. What is Jada's income as a percentage of Reggie's? How many times as large as Reggie's income is Jada's? So we have the more than here. More than means we're going to do 100 plus our percentage. So 100 plus 200 is 300% of Reggie's income. 300% is 3 times as much as Reggie's. A store is having a 25% off sale. How does an item's sale price compare to its original price? Well, 25% off means 25% less than. So we're going to take the 100 minus the 25 and get 75% of the original. So 25% less than is 75% of the original. And then, for example, it says if your original price was $100, the sale price would be $75. So, a few more examples here practicing this concept. The area of Norway is 24% more than the area of Colorado. So, Norway's area is what percent of Colorado? Well, more than means I'm going to add 100. So, 124%. The net worth of Warren Buffett is 14.5% less than the net worth of Bill Gates. So Warren Buffett's net worth is what percent of Bill Gates' net worth? Well, less than means we want to subtract it from 100, and that's going to give me 85.5%. A store is having a quarter off percent, I'm sorry, that should say off, or a 25% off sale. The sale price for an item with a regular price of $120 is what? Well, first we need to find that percent. So if it's 25% off, that means we're going to take 25% off and pay 75% of the value. And now we've done this before. 75% of 120 means we need to take 75% or 0.75 decimal form times 120, and we will get a value of $90. So how do you know if you're doing a absolute change or a relative change? Because sometimes we're going to have to find percentages of percentages. Well, remember that if the final answer has the percent word in it, that's our relative change. And if we're just calculating the overall difference, that is an absolute change. So, an example, if a bank increases its rate from 3% to 4%, the interest rate increased by 1 percentage point. That is absolute. The relative would be taking that 1 percentage point divided by your original 3% and timesing by 100. 1 divided by 3 times 100 is 33%, and your relative will always have the percent symbol in the answer. So, what do we do when we want to solve some percentage problems? Well, if the compared value of is p% more than the reference value, then we're going to use this concept here of taking our compared value is equal to 100 plus our percent times our reference value. And we basically did that with the 25% off sale, except that we did subtraction here because it was less than, and that's what it says down here. So if it's asking less than, you're going to use minus instead of plus. So more than, you'll use plus, less than, you'll use a minus sign. And then we can also rearrange this equation to find the reference value as the compared value divided by 100 plus P. Describe the following as absolute change in percentage and relative change in percentage. The percentage of people accessing the internet worldwide increased from 16% to 54% in 2020. So we know we increased. So we're going to go 54% minus 16% for a total change of 38%. I'm going to write it this way. We increased 38%. But what is the actual percent change to go from 16 to 54? So that's absolute. Relative is going to take our increase of 38 divided by our original value of 16 times by 100. And that is going to give me a 237.5% increase. 237.5% means I more than doubled my percentage here. You purchase a shirt with a labeled pre-tax price of $21. The local sales tax rate is 6%. What is your final cost including tax? Well, the final cost is going to be the labeled price plus our 6% of the labeled price. So what I can do is I can take 100 plus 6% times by the labeled price, or 106% times 21, which is 1.06, divide by 100 to get the decimal version, times by $21. The total I will pay is $22.26 for that shirt. Between 2007 and 2020, the number of twin births in the United States has decreased by 11%. If there were 138,800 twin births in 2007, how many occurred in 2020? Well, if we've decreased by 11%, I am now 89% of my reference value. So I want to find 89% of that 138,800. 89% is 0.89 of means I'm going to multiply by 138,800. And if you grab a calculator and type that in, any scientific calculator will do. I had 123,532 twin births that would have occurred in 2020. One thing I would like to draw your attention to, though, is the abuse of percentages. Beware of things like this. If you get a 10% pay cut followed by a 10% raise, you are not back to where you started. Or you see something that is less than nothing. Decreasing your caloric intake by 150% to lose weight. You cannot decrease something by more than 100%. And we cannot average percentages. So if 70% of the boys and 60% of the girls in a class voted to go to the water park, we cannot say, well, 65% of the students decided to go to the water park. We cannot do that. So first example with this, a stockbroker offers the following defense to angry investors. I admit that the value of your investments fell 60% during my first year on the job. But this year, their value has increased by 75%. So you're actually 15% ahead. Let's evaluate this defense. In order to evaluate this, we're going to imagine that we started with $1,000. If we lost 60% of the value, we would lose $600, leaving you with $400. So after that first year, you'd be down to $400. During the second year, we gained 75%. So 400 was what we had. 75% of 400 means we went up $300. And at the end of the second year, I'm now at $700. I am not even back to where I started from, which was my $1,000. So I am not 15% better than I was to begin with, because anytime you take a loss and then a gain, your gain is now on a different value and it's not going to be as much because it's on a lower value. A store advertised that it will take 150% off the price of all merchandise. What would happen when you go to checkout to buy a $500 item? Well, if the price were 100% off, the item would be free. So to say that something is 150% off, that would mean the store would be paying you to buy or take their product. So clearly, if that is ever seen, it was probably a typo or a mistake, because you cannot take more than 100% off of something. So this last example is going to explain why we can't average two of these together. In baseball, a player's batting average represents the percentage of at bats in which he got a hit. For example, a batting average of .350 means that a player got a hit 35% of the time he batted. Suppose a player had a batting average of .200 during the first half of the season and .400 during the second half of the season. Can we conclude that his batting average for the entire season would be a 300, given that that's the average of 200 and 400? Why or why not? So based on what we talked about of abuse of percentages here, no, this isn't going to work. And here's why. We are going to have two different reference values. Let's say for this first half of the season, he went to bat 300 times. And in the second half of the season, he only went to bat 200 times. These are not the same whole reference values here. So my total is now 500 at bats. So the first half batting average of 200 means that he got 20% of his 300 at bats. That means he got 60 hits. If we did the .400, that means 40% of his second half at bats. 40% of 200 is 80 hits. Now we can then calculate on the next slide what his actual percent is. For the entire season, he got a total of 140 hits out of his 500 at bats. So his season batting average would be 140 out of 500, which is 28%. 28% is not 300 batting average of 300, or 30%. So because the total values could be different in the two groups, we cannot just average these two values together. This is the end of 3A. Please move on to section 3B.